It is all about the number 10 today. Keep 10 in your mind because we're going to be talking about 10 all day in math. Our number system is a base 10 system, and you're going to find out what that means right now. Today's lesson is all about the number 10. Our number system has 10 digits. That is not an accident. Our number system is a base 10 system. That means our number system is based on the number 10. What do I mean by that? Well, let's look at our place value system. You know that we've got the ones place, the tens place, and the hundreds place. It's based on 10 because each place can hold up to just 9 of each place. So for example, I've got 4 ones, 5 ones, 6, 7, 8, 9. But when I get to 10, I can no longer use that place value. These 10 need to make a 110. Here, come on, work with me, people. These can be made into a tens rod, and now it needs to go to the next place value. That was easy. Now, the tens place, I can have 110, 2 tens, 3 tens, 4 tens, 5 tens. I think you know where we're going with this. 6, 7, 8, 9. I can have up to 9 tens in the tens column, but as soon as I add a 10th 10, I need to switch it over to the hundreds column and it becomes a flat. Our number is a base, our number system is base 10. Each time you get to 10 of one place, you need to go up to the next place value, and so on. If I could put 2, 3 hundreds, all the way up to 9 hundreds in the hundreds place, but once I got to 10 hundreds, I'd have to move over to the thousands place. So that's how our number system works. You can only get one digit in each place value. I couldn't put 2 digits in one place. If I have a tens digit, it needs to go over there in the tens place. So remember yesterday we were talking about the value of digits. So the value of 4 would be 4. It's 4 ones. And then if I move that 4 over into the tens place, that becomes 40 for tens, and then that 4 over here for hundreds is written like this, 400. So because we have a base 10 system, it's really easy to tell how much larger I make a number when it goes to the left. So let me say that again. 4 ones, if I take that 4 and I move it to the tens place, 40 is 10 times larger than 4 because we've got a base 10 system, and each time you go up one place value, remember you need 10 of something to go up to the next place value. And likewise, if you move this 4 into the hundreds column, then that 4 hundreds is 10 times bigger than 4 tens. Each time you move one column to the left, you're getting 10 times larger. 4 tens is 10 times larger than 4 ones, and 4 hundreds is 10 times larger than 4 tens. So let's look at the number 333. Each time you go to the next place value to the left, the value of that place is 10 times larger than the place to the right. 10 times larger. So 3 hundreds is 10 times larger than 3 tens, and 3 tens is 10 times larger than 3 ones. Now you might be asking, does that work backward, Mr. Brandt? Yes, it does. Great question. So 3 hundreds, when you go down to the right, then the tens place is 10 times smaller than the hundreds place, and the ones place is 10 times smaller than the tens place. Remember, our number system is a base 10 system, so each place value is 10 times larger than the one to its right. Or when you go back down to the right, each place value gets 10 times smaller. Okay, so I've got 30 in our place value chart. What number is 10 times larger than 30? Well, remember, every time you go one place value over, it's 10 times larger. So if I just moved that 3 over to the hundreds place, and I'll put a 0 there so you can tell there are no tens anymore, then you get 300. 300 is 10 times larger than 30. 10 times. What about 300? What is 10 times larger than 300? Well, just move the 3 over. I have another 0 over here. There we go. 3,000. Every time you move that digit to the left, the resulting number is 10 times larger. This works for multi-digit numbers as well. Now I've got a 2-digit number. What is 10 times larger than 21? Well, move the 2 over one place value and the 1 over a place value. Put a 0 in there to hold the place because there's nothing in the ones place. And 10 times more than 21 is 210, as you can see. What is 10 times greater than 210? Let's move each of these digits over a place. Boom, boom, boom. Bring that in, and it's 2,100. Anytime you moving a digit over one place, you're changing the value of that digit to be 10 times greater than it was. In this case, the value of the 2 in 210 is 200 because the 2 is in the hundreds place. But in 2,100, the 2 is in the thousands place, so the value of the 2 is 2,000. And 2,000 is 10 times larger than 200. Just by moving that 2 up one place value to the left, we changed its value to one that was 10 times greater. All right, mathematicians, our magic word today is base 10. Bonus points for extra exclamation marks when you put it on your seesaw assignment. Just type in base 10, exclamation mark, exclamation mark, exclamation mark, put a bunch in there, and we'll see you at the live math.